So we're going to look at introducing the idea of power in this lesson. Now, to introduce it, just think about some simple ideas. I can run 100 metres, but I can't do it as fast as Usain Bolt. I can run a mile, but I can't do it in under 4 minutes like many world-class athletes can. If you ask most people that you're going to have to travel a mile, you can either walk or you run, most people would choose walk. And what all of these things have in common is the time. It takes pretty much the same energy to run a mile as it does to walk a mile. But when you're walking, you can spread that energy over a much longer period of time, so that each second you don't have to supply as much energy. And those of you who do biology, you'll meet the ideas of aerobic and anaerobic respiration that your muscles need to use to transfer the energy required. And basically it's much less efficient to supply a lot of energy in a small period of time. So this is what the concept of power is based on. In everyday language the words are quite often interchanged, but power in physics is defined as the rate at which energy is transferred, or in other words, the energy transferred per second, or even in the other set of words, the work done per second. That's the definition. That then leads to a formula that power is energy transferred divided by time, or it's usually written in that form, P equals E over T. And the unit of power is the watt. Our energy is in joules and our time in seconds, standard units for those. So for example, here's some electrical devices, particularly with energy efficient light bulbs here, for instance, 26 watts, 15 watts nowadays. That's telling you how much energy they use each second. So a smaller number means it's using less energy, whereas this, maybe from an iron or a heater or something like that, much larger amount of power, it's using a lot more energy each second. If we look at a worked example based on that then, so we worked out how much energy was transferred in 1 hour, then the power for the iron, 1400, and the time is 1 hour times 60 minutes times 60 seconds, and you're trying to work out the energy. So show your substitution, substitute the numbers in, and then rearrange the amount of energy. Compared with this, what we call energy efficient light bulb, the power is only 26 watts each second. So in 3600 seconds, that'll give you 9.4 times 10 to the 4. So you're nearly 100 times more energy for the iron in an hour than you would for the light bulb. And in general, heating devices do tend to use much more energy than other devices. You've got a lot of heat getting produced because of the resistance of the heating element.